Imagine holding a complex design in your mind, hitting print, and watching as a physical object emerges, layer by intricate layer, right before your eyes. It sounds like something straight out of a futuristic movie, doesn't it?
Yeah.
But here's the surprising part. This technology, what we now call 3D printing or additive manufacturing, isn't some brand new sci-fi fantasy. Its earliest concepts actually stretch all the way back to the 1940s.
It's true. And today, we're embarking on a deep dive into the world of 3D printing. We're going to unpack its truly fascinating evolution, from those visionary early ideas to its current widespread applications across almost every industry you can imagine. You'll discover the incredible variety of materials and processes it uses, and by the end, you'll see why this technology is so much more than just, a niche industrial process.
That's our mission today, to give you a clear, comprehensive understanding of this transformative technology. We want to deliver those aha moments and surprising facts without overwhelming you with technical jargon. You'll learn how it works, its immense practical benefits, and its profound social and environmental impacts. You'll understand why it's changing everything from how we make food to how we think about intellectual property. So are you ready to unpack this?
Let's start with the basics. When we talk about 3D printing or additive manufacturing, what are we actually saying? We're referring to the construction of a three-dimensional object from a digital blueprint, usually a CAD model. The key is how it builds. By adding material, whether that's plastics, liquids, or powders, typically layer by layer, all under precise computer control.
Okay, adding layer by layer. But what's interesting is that when this technology first emerged in the 1980s, it wasn't even called 3D printing. What was its primary use back then? What did people call it?
Good question. Initially, it was mainly used for creating functional or aesthetic prototypes. And the term of choice back then was rapid prototyping. The focus was really on quickly bringing a digital design into the physical world to test it out.
Rapid prototyping. Got it. And then the terminology itself started to shift.
Absolutely. In the 2000s, additive manufacturing, or AM, gained a lot of traction, particularly in metalworking and the production of final end-use parts. This term really emphasized the process of adding material, which offered a stark contrast to subtractive manufacturing.
Right, that's the traditional way, like machining.
Exactly. Subtractive manufacturing became kind of a retronym, a term coined after the fact, to describe those traditional processes where you remove material to create a shape.
So fast forward to the early 2010s, and 3D printing and additive manufacturing became almost interchangeable umbrella terms for most people. But were there still distinctions in how they were used, maybe more professionally?
Definitely. 3D printing often got associated with the lower-cost, more consumer-focused machines that were starting to appear, while AM remained the more formal term, preferred by industrial producers and standards organizations. And while they're often used synonymously in casual conversation, some manufacturing experts still view AM as a broader concept. They see it as encompassing 3D printing plus other aspects of the overall manufacturing process.
Okay, so there's still some nuance there.
But here's the real game changer, regardless of the term you use. This technology can produce incredibly complex shapes, geometries that would be otherwise basically impossible, or at least infeasible, to construct using traditional methods.
Like what? Give me an example of something that's just, impossible without it.
Okay, think about creating hollow parts with really intricate internal structures, like a honeycomb-like truss inside an object. With traditional methods, machining that out of a solid block, that would be incredibly difficult, if not impossible. But with 3D printing, you can essentially grow these internal geometries layer by layer, which significantly reduces the weight of the part and minimizes material waste. It's a complete rethinking of design possibilities.
That's a huge advantage.
Yeah.
And if you're wondering which type of 3D printing you're most likely to encounter today, as of 2020, the most common process is fused deposition modeling, or FDM. That's the one that works by extruding a continuous filament of thermoplastic material, building up the object layer by layer.
Yeah, that's the one most people picture, I think, the filament-based printers.
Now let's go back in time, because the history here is way longer and more intriguing than many might imagine. The early seeds of this concept were sown surprisingly early, not in a lab, but actually in the pages of science fiction.
Indeed. It's pretty cool, actually. Murray Leinster's 1945 short story, Things Pass By, described a constructor machine. It made drawings in the air with hardening plastic. Sounds familiar, right? And then Raymond F. Jones's 1950 story, Tools of the Trade, mentioned something he called a molecular spray. These were truly visionary ideas, especially when you think about what computers were like back then. Barely a concept.
Right, so the ideas were out there in fiction. But they didn't stay fictional for long. In 1971, Johannes F. Gottwald secured a patent for what he called the liquid metal recorder. That sounds like the real deal. What was it?
It was essentially a continuous inkjet device, but for metal, and it's considered by many to be the first patent describing 3D printing with rapid prototyping in mind. And his goal was incredibly forward-thinking for the time. He wanted to minimize material use and even allow for salvaging materials for reuse. So even back then, there was an awareness of efficiency and sustainability.
That's fascinating. And the concept was popping up elsewhere, too.
Yeah, David H. Jones laid out the concept more broadly in a 1974 New Scientist column. It shows the idea was circulating among innovators, not just in one person's head.
Okay, so the seeds were planted in the 40s, 50s, and 70s. But the true birth of modern additive manufacturing really kicked off in the 1980s. Were there many different people or groups trying to crack this code then?
Absolutely. It was kind of a race, in a way. In Japan, Hideo Kodama invented additive methods for plastic models using photo-hardening polymers back in 1980. He even filed a patent for his XYZ plotter in 1981. But here's an aha moment about innovation. His project got shut down. Why? Lack of interest and a tiny budget. We're talking $545 a year.
Wow, $545 a year for potentially revolutionary tech.
It's wild, and it's fascinating how many groundbreaking ideas in the 80s were dismissed by companies as lacking business perspective, ideas that, later became billion-dollar industries.
It really speaks to the long gestation period of truly disruptive technologies, doesn't it? Sometimes the infrastructure, the market, or even just the collective imagination isn't ready yet. Meanwhile, in the U.S., others were also making strides. Raytheon got a patent in '82 for depositing powdered metal with a laser. And in '84, Bill Masters filed the first U.S. 3D printing patent for a computer-automated manufacturing process.
And you won't believe this in France. Inventors also filed a patent for stereolithography that same year, 1984. But again, it was abandoned by companies due to lack of business perspective, that recurring theme.
Unbelievable. But then came the person really credited with the breakthrough for the modern era, Charles Chuck Hull. His company, 3D Systems, filed its own patent in 1984, defining stereolithography, using UV light to cure photopolymers. What made his contribution so significant?
Hull's impact was just immense. He didn't just define the process, he also created the STL file format. That's the standard file type we still use. And he developed those critical digital slicing and infill strategies. You know how the machine builds the inside of the part. 3D Systems then released the first commercial 3D printer, the SLA-1, in 1987 or maybe 88. That was a pivotal moment.
Okay, so Hull and 3D Systems with stereolithography, and then another major player emerged soon after.
Right. S. Scott Crump of Stratasys developed fused deposition modeling, or FDM, in 1988. That's the filament extrusion method we talked about earlier. Stratasys marketed its first FDM machine in 1992. So you had these two major players really solidifying the core technologies in the late 80s.
But at this point, were these machines even remotely accessible? Like, could a small business or an individual even dream of owning one?
Oh, not at all. Not even close. To put that in perspective, owning a 3D printer back in the 1980s would set you back upwards of $300,000, which, if you adjust for inflation, is something like $650,000 in today's money.
Whoa. Okay, so strictly for large corporations and very well-funded research labs then.
Exactly.
So moving into the 1990s and through the 2000s, we saw a significant expansion and a gradual move towards accessibility. The 90s brought us metal printing processes, right? Like sintering and melting powders.
Yeah, things like selective laser sintering, SLS. It showed that tech wasn't just limited to plastics, and new material deposition techniques also emerged, like microcasting and sprayed materials. Interestingly, the actual term 3D printing itself originally referred specifically to a powder bed process developed at MIT in 1993. That one used inkjet print heads, kind of like your desktop paper printer, but with powder and binder.
Huh. So the term had a more specific origin. But for much of the early 2000s, these printers were still pretty niche.
Very much so. Still largely confined to big manufacturing and research labs, mostly used for low-accuracy modeling in fields like architecture and medicine, mainly because they were still so expensive.
So how did this niche, expensive technology start to become more democratic? What was the turning point that really began to open it up?
That came largely, I'd say, through the open source movement. It was a huge catalyst. You had Adrian Boyer's ReapRap project, started around 2004. Their goal was amazing: Design printers that could actually print most of their own parts.
Self-replicating printers.
Yeah, about 70% of their own parts. It showed the potential for self-replication and dramatically lower costs. And then the Fab at Home project in 2006 aimed for similar low-cost open-source fabrication for everyone.
Those sound like crucial steps. But the real game changer for accessibility, the true inflection point, that came in 2009, right? What happened then?
That's when the key patents for the FDM printing process Scott Crumb's Stratasys patents expired. And that just opened the floodgates. Suddenly, a whole new wave of startups could jump in and build on that FDM technology. It led to this boom in commercial FDM 3D printers becoming far more accessible to the public. It really ushered in a new era.
And that leads us right into the 2010s and 2020s, a period of, well, mainstream adoption and absolutely incredible innovation. By the 2010s, metal end-use parts, actual functional parts, not just prototypes, began to be grown by additive manufacturing. You mentioned it really took off, especially in aviation. Can you give us a concrete example of that impact?
Absolutely. It's a perfect case study. Take GE's LAP jet engine. It now integrates 3D printed fuel nozzles, the original design for that nozzle, 20 separate parts that had to be assembled. With 3D printing, they condensed it into just one single part.
Oh, 20 parts down to one.
Yeah. And that didn't just simplify assembly, it also achieved a 25% weight reduction, which, for an aircraft, translates directly into fuel efficiency and reduced emissions. It's a massive win.
That's incredible. It's not just about efficiency then, it's about pushing the boundaries of what's even designable. You can create these internal geometries that were impossible with traditional methods, leading to lighter, more fuel-efficient, maybe even safer parts.
Yeah.
And this accessibility just kept growing, right? The prices kept dropping.
Oh yeah, the price continued to plummet. While commercial printers were still over $2,000, maybe, in 2014, by 2020 you could find decent quality FDM printers for less than US $200. That made 3D printing genuinely accessible to most people, hobbyists, schools, almost everyone.
And the breakthroughs just keep coming thick and fast now. In 2021, the world's first fully 3D printed prosthetic eye was given to a patient in the UK. That's amazing. Just this year, 2024, the world's largest 3D printer was unveiled at the University of Maine. It's, 96 feet long?
96 feet. It can print enormous things like molds for boat hulls or even small building structures. It's huge. And we've also seen AI-designed synthetic bone with record shock absorption also this year. And just in July, 3D-printed artificial blood vessels were developed that are as strong as natural ones. This is truly a technology accelerating at an incredible pace, pushing the boundaries of engineering, materials science, even biology.
Okay, so beyond the sheer cool factor and this rapid pace of innovation, what are the sort of unseen benefits? What makes 3D printing such a profound game changer? Why is it so transformative?
Well, it goes far beyond just replicating traditional manufacturing methods. 3D printing offers unparalleled design freedom. Designers aren't constrained by old rules. Think about individualization, creating custom-fit products easily. Prosthetics, tools, anything. It enables decentralization of production. You don't necessarily need a huge factory anymore. You could print things closer to where they're needed. And critically, it allows for processes and shapes that were simply impossible before.
That's right. And for businesses, it's a huge win for efficiency and customization. It dramatically speeds up prototyping, going from a digital concept to a physical object you can hold much, much faster. It can reduce manufacturing costs, especially for complex, low-volume parts. And it enables a level of product customization that's just not feasible with traditional mass production, often while improving product quality, too.
And its capabilities extend into entirely new frontiers. We're talking lightweight construction for vehicles and aerospace, which saves fuel. Critical repairs and maintenance, printing spare parts on demand, highly personalized prosthetics, as we mentioned, and even bioprinting for medical applications like tissues and eventually maybe organs. That's the holy grail for some researchers.
You're showing up everywhere.
Yeah, it's making inroads in the food industry, believe it or not. Rocket building, printing complex engine parts, design and art, obviously. It can even be used to produce components for renewable energy systems, like custom battery casings or parts for wind turbines. The versatility is just astounding.
What's also incredibly impressive, you mentioned earlier, is its precision and its potential for waste reduction. How does it achieve that?
Well, it can produce highly complex geometries with incredible precision and accuracy that's particularly valuable in fields like microwave engineering, where the exact shape is absolutely crucial for function. And because additive manufacturing only adds material precisely where it's needed, layer by layer, it generates minimal waste compared to traditional subtractive methods that start with a block and cut away everything you don't need.
Right, carving away material is inherently wasteful.
Exactly. So AM dramatically reduces material costs, the environmental impact of that waste, energy consumption, and ultimately our overall carbon footprint. It's just a much leaner way to make things in many cases.
Okay, so we understand why the benefits are huge.
Yeah.
How does all this magic actually happen? Let's talk about the general principles behind bringing a 3D idea into physical reality. Where does it start?
It all starts with modeling. You need a digital blueprint. Your 3D printable model is typically created using computer-aided design or CAD software. That's the most common way. You can also use 3D scanners or photogrammetry to capture existing objects and turn them into digital models. But CAD models generally lead to cleaner, more accurate prints with fewer errors because you're designing it digitally from the ground up.
Okay, so you have your digital model, then it needs to be saved in a specific file format the printer can understand. The most common one is STL, right? Stereolithography format. What is that exactly?
Right, STL is the workhorse. It represents the object surface using triangulations, basically. It covers the surface in a mesh of tiny triangles. It's simple, widely supported, but for really complex parts with lots of curves, an STL file can become enormous and a bit clunky.
So there are newer formats too.
Yeah, that's where AMF, the additive manufacturing file format, comes in. It was introduced around 2011. It uses curved triangulations, which helps manage those large file sizes better for intricate designs, more efficient. And importantly, before you print, any digital file needs a quick check for errors, like are there holes in the mesh? Do parts overlap incorrectly? These need to be repaired digitally to ensure a clean, successful print. This is especially true for models that came from 3D scans.
Gotcha. Check and repair the file. And here's where the literal layers come in, the crucial step of slicing. What happens then?
Right, slicing is key. A software program, logically called a slicer, takes your repaired 3D model. It digitally cuts the object into a series of incredibly thin, horizontal, two-dimensional layers, like a stack of paper printouts. This software then generates something called G-code. G-code is essentially a set of highly specific instructions tailored for your particular 3D printer model. It tells the printer exactly where to move its print head, how much material to extrude, the temperature, the speed, everything it needs to know to build that object layer by layer.
And the quality of your print depends heavily on the resolution, right? What does that mean in 3D printing terms?
Exactly. Printer resolution refers to a couple of things. First, the layer thickness, how thin each slice is. Typical layer thickness might be around 100 micrometers, which is about the width of a human hair. But some high-end machines can print layers as thin as 16 micrometers. That allows for astonishingly fine detail. The other part is the XY resolution, which is how finely the printer can move across the print bed horizontally.
Okay, so finer layers and finer XY movement mean more detail. What about how long it takes?
Well, build time varies hugely, obviously. A small, simple object might print quickly. A large, complex one takes longer. But compared to traditional manufacturing methods, especially for prototypes or custom parts, which could take days or months, additive systems can often reduce this to mere hours. It depends on the object's complexity and size and the specific printing process, but it's generally much faster for one-offs or small batches.
Okay, so that covers the basics from digital file to printed object. But the process doesn't necessarily stop when the printer finishes, right? There's often post-processing involved, and the variety of actual printing processes is truly astounding. Let's talk finishing first.
That's right. Getting the print off the machine is often just the start. Finishing can involve quite a bit. Common steps include sanding or bead blasting to get smoother surfaces, especially if you need a really polished look or feel. 3D prints often have visible layer lines, and finishing helps remove those. For some plastics, like ABS, you can even use chemical vapor processes. Acetone vapor, for example, can smooth the surface quite effectively by slightly melting the outermost layer.
Interesting, and I've heard about annealing as a post-processing step. What does that do?
Annealing is basically a heat treatment, like you might do with metal or glass. For 3D printed parts, particularly certain plastics, it helps improve the bonding between the layers and can enhance the overall mechanical properties, making the part stronger and more durable. You just have to be careful during the process, because it can sometimes cause the part to warp slightly.
And sometimes you combine printing with traditional methods.
Yeah, that's called additive or subtractive hybrid manufacturing, or ASHM. Pretty neat concept. You might 3D print a complex shape that's close to final form, then use traditional CNC machining to finish critical surfaces with very high precision and accuracy. It combines the best of both worlds.
What about that stair-stepping effect you sometimes see on curved surfaces because of the flat layers?
Right, that's inherent in layer-based manufacturing, but it can be minimized. Some advanced slicers support variable layer heights, where the printer uses thinner layers on shallow curves and thicker layers on steep vertical sections. That helps smooth things out. And of course, parts can always be painted. Although some multi-material printers can actually print in multiple colors right from the start, which is cool.
And one last thing about finishing supports.
Ah, yes, supports. Crucial, but sometimes annoying. If your design has overhanging features, the printer needs to build temporary support structures underneath them as it prints. These supports then have to be carefully removed after the print is done, either snapped off, cut away, or sometimes dissolved if they're made of a special soluble material.
Okay, makes sense. Now, materials, you mentioned it started with polymers, but now it handles metals, chocolates, ceramics, diverse range. I heard the earliest patented material was actually a hot melt metal alloy. For the personal printers most people might have at home, what are the common plastics?
Yeah, for those desktop FDM printers, the two most common polymers you'll see are PLA polylactic acid, which is popular because it's relatively easy to print and derived from renewable resources like cornstarch. And the other big one is PETG, which is basically a modified version of the plastic used in water bottles. It's a bit more durable and temperature resistant than PLA, but the really cutting edge stuff is in multi-material 3D printing.
Right, you mentioned that. Tell me more. How does that work?
It allows for creating these complex, heterogeneous arrangements of different materials within a single printed object. The software lets you specify the material properties for each tiny little volume element, or voxel, think of it as a 3D pixel. So instead of just printing a solid block of one material, you can design a part where, say, one section is rigid and strong, and it transitions smoothly into a section that's soft and flexible, all printed in one go.
So you could print like a tool with a hard metal tip and a soft rubber grip, all as one piece.
Exactly. That's the kind of capability it unlocks. It gives designers incredible control over material properties spatially. And this opens doors for really cool innovations, like 3D printed pills that combine multiple medications with different release profiles in one tablet. That could potentially decrease risks for patients by delivering precise, tailored dosages automatically.
That's amazing potential. And then there's the truly futuristic sounding 4D printing. What on earth is that?
Yeah, 4D printing adds the dimension of time to 3D printing. The idea is that the printed object isn't static. It's designed to change its shape or its function over time, usually in response to some external stimulus like temperature, light, or moisture. It allows for creating dynamic structures, things that can self-assemble or change rigidity on command.
Like a flat sheet that folds itself into a box when you heat it.
Sort of, yeah. Or materials that change their porosity. It could lead to entirely new classes of smart materials and devices. But it's still very much in the research phase. It requires significant advancements in controlling the material's microstructure during printing and developing specialized software to design these transformations.
Okay, mine's slightly blown by 4D printing. Now, you mentioned earlier there are 7 main categories of additive manufacturing processes defined by ISO and ASTM standards. We obviously can't dive deep into every single one, but what are some of the key families, the main types of 3D printing processes our listeners are most likely to encounter or hear about? What makes them distinct?
Great question. It helps to group them. You broadly have processes based on material extrusion, like the common FDM printers squeezing out melted plastic filament. Then there's vat photopolymerization, which uses light, usually UV light, to selectively cure liquid resin into a solid. And another big category is powder bed fusion, where you use a high-power energy source, like a laser or an electron beam, to melt and fuse fine powders together layer by layer. Think of them as different tools for different jobs. Each excels in certain areas: materials, resolution, speed, strength.
That's a helpful breakdown. Can you quickly give us a sense of what each of those 3 main types is best suited for? Let's start with material extrusion, FDM.
Okay. Material extrusion, like FDM or FFF, fused filament fabrication, is the most common, especially for consumers and schools. It's great for rapid prototyping, making household gadgets, educational models, jigs and fixtures. Usually uses thermoplastics like PLA or ABS or PTG. Newer variants, like fused particle fabrication, FPF, are interesting because they can use plastic pellets directly, even from recycled sources like milk bottles, which is great for sustainability and cost.
Okay, versatile and accessible. What about powder bed fusion? That sounds more industrial.
It generally is, yeah. Techniques like selective laser sintering, SLS, which fuses polymer powders, or selective laser melting, SLM, and electron beam melting, EBM, which melt metal powders. This is where you get incredibly strong, high-resolution, geometrically complex parts, often made from metals like titanium or aluminum or high-performance polymers. It's perfect for demanding applications like aerospace components, medical implants, or intricate tooling. It's a very high-precision, high-strength method.
Right, so metal parts for jet engines, that kind of thing. And the third major one, vat photopolymerization.
This family includes methods like stereolithography, SLA, which was the first commercialized process, and digital light processing, DLP. They work by curing liquid photopolymer resins with UV light. These systems can create incredibly tiny features, sometimes sub-micron, and produce parts with very smooth surface finishes and intricate details. So they're great for things like highly detailed visual prototypes, jewelry casting patterns, dental molds and aligners, or microfluidic devices.
Fascinating how diverse they are, even within those main groups.
Hmm.
And beyond these three, there are others, right? You mentioned binder jetting.
Yes, binder jetting is interesting. It works by depositing a liquid binding agent, like a glue, onto thin layers of powder, which can be sand, metal, or ceramic. The binder holds the powder together in the shape of the layer. After printing, you often have what's called a green part. Think of it like an unfired clay pot. It holds its shape but isn't very strong yet. It usually needs post-processing, like curing or sintering in an oven, to achieve final strength. A key advantage is that it can produce full-color prototypes by using colored binders, and it can be used for large parts, like sand cores and molds for metal casting.
Okay, and what about CAL, computed axial lithography? That sounds different.
It is different. CAL is a newer volumetric method. Instead of building layer by layer, it creates the entire object at once. It does this by projecting a series of 2D images, like a movie, from different angles into a rotating cylinder of photocurable resin. Where the light intensity exceeds a certain threshold, the resin solidifies simultaneously. It can be much, much faster than layer-based methods for certain geometries, and it can even print around existing objects, essentially embedding them within the print, which is pretty unique.
Oh, wow, okay. And LAM, liquid additive manufacturing.
LAM is specifically designed for depositing high-viscosity liquid materials like silicone rubber or other elastomers. The material is extruded and then typically vulcanized, usually by heat, to solidify it. It's great for making flexible, rubbery parts.
And DED, directed energy deposition.
DED uses a focused energy source again, typically a high-power laser or an electron beam, to melt material as it's being deposited. The material is usually fed in the form of metal powder or wire directly into the melt pool created by the beam. This isn't just for building new parts from scratch. It's increasingly used for adding features to existing parts or for repairing high-value components like turbine blades. Even conventional welding processes like gas metal arc welding can be adapted for DED.
So you could repair a worn-out metal part instead of replacing it entirely.
Exactly. Huge potential for maintenance and repair in industries like aerospace or defense. And just to round it out, there's even cryogenic 3D printing, which forms solid structures by precisely depositing and freezing liquid materials as they land, requiring a carefully controlled cold environment. It's still quite specialized, but shows the range of possibilities.
It's an incredible toolkit. So with all these different processes and materials, where are you actually seeing 3D printing making a difference today? The applications are incredibly diverse and seem to touch almost every part of our lives now. Which ones truly stand out to you as revolutionary? Where does it change the game in a way nothing else really could?
That's a tough one because there are so many. But for me, if I had to pick one area where the impact is truly profound and unique, it's probably personalized medicine. Things like custom prosthetics that fit perfectly, patient-specific surgical guides, dental aligners, hearing aids, and looking forward, the potential of bioprinting. Imagine printing replacement tissues or eventually even complex organs specifically tailored for your body, maybe even built using your own cells to avoid rejection. That's not science fiction anymore. Labs are actively working on this.
That's a truly profound shift. And it goes beyond just replacement parts, right, into surgery itself.
Absolutely. Surgical use has actually started way back in the mid-1990s. Initially, it was mostly anatomical modeling, printing a copy of a patient's bone structure, for example, so surgeons could plan complex reconstructive surgeries beforehand. That evolved into personalized implants designed specifically for that patient. And now, virtual planning combined with 3D printed surgical guides and instruments is used in things like joint replacement surgery and complex facial reconstruction. There have even been cases of 3D printed bioresorbable tracheal splints used to save newborns with breathing problems.
Wow. And orthopedic implants.
Increasingly used there, too. 3D printing allows for creating implants with porous structures, kind of like natural bone, which can help the patient's own bone grow into the implant for better integration and stability. The hearing aid and dental industries were early adopters and are now huge users of 3D printing for custom shells and aligners. And in pharmaceuticals, as I mentioned, it's enabling novel drug formulations. Personalized dosage forms tailored to individual patient needs may be combining multiple drugs or having specific release profiles. Some people expect 3D printers to eventually be common in hospitals and pharmacies for on-demand drug production.
And we even saw it play a role during the pandemic.
We did. During the early days of COVID-19, when supply chains for personal protective equipment were strained, 3D printers were crucial. Volunteers and maker communities around the world started printing face shield frames and other essential items to supplement the supply for healthcare workers. It highlighted the power of distributed manufacturing.
That's a truly powerful impact. Okay, beyond medicine, what other areas are seeing a radical transformation thanks to 3D printing?
Transportation is definitely a huge one. It's really taken off in the design and production of cars, trucks, and especially aircraft. We talked about GE using it for turbine parts. The Koenigsegg 1.1 supercar uses several 3D printed components for lightweighting and performance. There was a car called the Irby, which was notable for having a 3D printed body and windows maybe more of a concept, but it showed the potential. And Airbus's A350 XWB aircraft reportedly includes over 1,000 3D printed components.
1,000 parts on one plane model. That's significant.
It is. It's often for non-critical components like brackets or ducting, but it adds up in terms of weight savings and design flexibility. And remember that GE Aviation helicopter engine example, reducing the part count from 900 down to just 16. That's just astonishing for an industry where complexity and weight are everything.
And the military is using it too, you mentioned.
Yes, for parts in jets like the Eurofighter Typhoon and for printing spare parts on demand for the Israeli Air Force, it highlights how critical this can be for rapid repair, logistics, and getting custom parts quickly in demanding, often remote environments.
Okay, aerospace and automotive are big. What about some more surprising applications? You mentioned food earlier.
How about food? Yeah. It's definitely experimental for the most part, but people are using modified 3D printers to squeeze out food materials layer by layer. Things like intricate chocolate designs, custom candy shapes, decorative pasta, even simple pizza bases. NASA is exploring it seriously as a way to limit food waste on long missions and create tailored, nutrient-specific meals for astronauts. And one bioengineer even developed a method for creating fibrous plant-based meat substitutes using a 3D bioprinter to mimic muscle texture.
Plant-based steak from a printer. That's wild. And fashion.
Fashion designers are definitely experimenting. We've seen 3D printed bikinis, shoes with complex lattice structures, even entire dresses. Nike has used it extensively for prototyping football shoe designs, getting physical models much faster. New Balance uses it for creating custom-fit midsoles for athletic shoes based on runner data. And you can now even get consumer-grade eyewear frames printed, sometimes customized to your facial measurements.
Another fascinating area you mentioned is cultural heritage. How is it being used there?
It's being used for preservation, restoration, and importantly, dissemination. Museums are using 3D scanning and printing to recreate missing pieces of ancient relics or to make replicas of fragile artifacts for handling or display. They've used it to reconstruct parts of archaeological monuments, like structures at Tiwanaku in Bolivia. Some museums even sell or give away the digital 3D models of artifacts in their collections, allowing people to print them at home. It brings history to life in a new way.
And artists are using it too.
Yes, artist Moresha Nalahari has a powerful project where she uses 3D printing for feminist activism by researching and digitally reconstructing cultural artifacts and treasures that were destroyed by ISIS, preserving their memory digitally and physically.
That's incredible. Architectural replication is another big one visually. That steel bridge in Amsterdam sounds amazing.
Right. It really is a feat of engineering. The world's first 3D printed steel bridge, unveiled in 2021. It spans 12 meters across the canal. It was created by robotic arms equipped with welding gear, essentially printing layers of stainless steel over 4,500 kilograms of it over a period of 6 months. It shows the potential for large-scale construction.
And even circuit boards, how does that work?
Yeah, 3D printing can streamline the manufacturing of printed circuit boards, PCBs. Traditional PCB making involves multiple steps like imaging, drilling, plating, etching. 3D printing can potentially reduce these. It uses special conductive inks, often polymer-based with silver particles, to print the conductive traces and insulating layers directly, building up the circuit layer by layer. This can significantly cut production time, especially for complex, multi-layered board designs or prototypes. And beyond all these industrial uses, let's not forget education and communities. 3D printing, especially with affordable open-source printers, is increasingly entering classrooms. It's great for teaching design thinking, rapid prototyping, and even for fabricating low-cost, high-quality scientific equipment, leading to what some call open-source labs. Many public libraries now also house 3D printers, providing community access to the technology. The maker Naomi Wu considers its use in Chinese classrooms for teaching design principles and fostering creativity a really key development for the future.
And of course, the hobbyists. That explosion after the FDM patents expired.
Exactly. Since around 2005, and especially after 2009, it's been huge for hobbyists. People use it for artistic applications, creating custom miniatures for gaming, making practical household items like replacement knobs or custom organizers, even building complex things like working clocks or gear mechanisms. As of 2019, it was estimated that maybe 2 million people worldwide had purchased a 3D printer for hobby use. It's a massive community now.
So with all this innovation and accessibility, especially with millions of people potentially printing things at home, the legal landscape must be trying to catch up. When it comes to intellectual property IP, things like patents, copyrights, trademarks, they might all apply.
Yeah.
What are the key issues people need to be aware of?
It's definitely a complex and evolving area. It's still somewhat unclear how existing IP laws will apply effectively if 3D printers become truly mainstream for personal or nonprofit use. Generally speaking, if an object you want to print is protected by active intellectual property, like a patent on its design or function, or copyright on its artistic expression, you would likely need a license from the rights holder to legally print it, especially for commercial purposes. Though, depending on the country and the specific situation, there might be exceptions for private or non-commercial use.
Okay, so patents cover the invention itself, the process, the machine, or a functional design, and they typically last about 20 years. Printing, using, or selling a patented item without permission could lead to infringement. Copyright is different, right? It covers the creative expression fixed in a tangible medium like a sculpture, a character model, or even the digital design file itself. That usually lasts much longer, often the author's life plus 70 years.
Exactly. And an important distinction, particularly in U.S. courts, is the idea of functional versus expressive features. Courts often rule that a feature of an object isn't protected by copyright if its shape is dictated purely by its function, unless that expressive element can be conceptually separated from the functional aspects. But how this applies to complex 3D models can be tricky, and international laws differ, which adds another layer of complexity if you're sharing files globally.
Right. Another area that generates a lot of headlines and legal debate is firearms. The U.S. Department of Homeland Security has pointed out that easily accessible 3D printable firearm files pose public safety risks because they could bypass traditional gun control measures and are hard to trace.
And that's a major concern for regulators. Attempts have been made to ban the online distribution of these files or restrict the printing of firearms. However, realistically, completely preventing production this way is very difficult. Online file distribution is notoriously hard to control once something is out there. Some legislators have proposed regulations on the 3D printers themselves, like requiring them to be unable to print firearm components. But advocates against such measures argue this would be futile, technically difficult, would harm the legitimate 3D printing industry, and could infringe on free speech rights regarding the distribution of information.
It's a really contentious issue, and internationally.
Internationally, where gun controls are generally much stricter than in the U.S., the ability to print firearms might be felt even more strongly, potentially undermining existing regulations in new ways.
Okay, moving away from firearms to aerospace, that's another highly regulated industry. How are bodies like the FAA handling 3D printed parts?
Right. In the U.S., the Federal Aviation Administration, FAA, is actively involved. They have to be, because all parts used on certified aircraft must meet stringent safety and performance standards and be FAA approved. They've been developing specific guidance and qualification processes for additive manufacturing techniques used in aircraft parts. It was a significant milestone back in 2016 when the FAA approved that 3D printed fuel nozzle for the GE LE Pat engine we discussed. It showed that AM parts could meet the rigorous standards.
So quality assurance is paramount there. Are general standards emerging for industrial 3D printing?
Yes, absolutely. Ensuring quality and consistency is critical for building trust and enabling wider adoption, especially in demanding industries. International standards bodies like ISO and ASTM are collaborating to develop standards. Examples include ISO's TEMM 529000-21, which covers general principles and terminology, and ISO STMM 52920.2023, which defines specific requirements for industrial additive manufacturing processes and production sites to ensure quality control. These standards are crucial for maturing the industry.
Okay, that makes sense. Finally, let's zoom out and look at the bigger picture. The health, safety, and the broader societal and environmental impacts of this technology, starting with health and safety. If you have a 3D printer at home or work, what should you be aware of? Are there risks?
Yes, there are potential hazards to be aware of, especially with desktop polymer printers. When you heat polymer feedstock materials like PLA or ABS filaments, they can release ultrafine particles, UFPs, and volatile organic compounds, VOCs, into the air. Some studies have linked exposure to these emissions to respiratory and cardiovascular issues, so good ventilation in the printing area is really important. Using an enclosure, maybe with a filter, is often recommended.
Okay, air quality is one thing. What else?
Well, the extrusion nozzles on FFM printers get very hot, typically 190 to 260 degrees Celsius, or even higher for some materials. That's a significant burn hazard if you touch it accidentally. For vat photopolymerization printers, they often use high-powered lasers or UV light sources. These are usually enclosed during printing for safety, but care should be taken during maintenance. And like any machine with moving parts, there's always a small risk of minor mechanical injuries, like getting a finger pinched in the moving gantry. Also, the electrical safety features on some lower-cost desktop printers might be minimal, though the operating voltages are generally low.
What about noise? Are they loud?
Noise levels can vary quite a bit between printers. Some are very quiet, maybe 15 decibels, while others can be quite loud, up to 75 decibels or more. The main sources of noise are usually cooling fans, the stepper motors that move the print head, and sometimes the bearings. People use various methods to dampen the noise, like putting the printer on a vibration-isolating mat or building a soundproof enclosure around it. Research into all these potential hazards is ongoing, and agencies like the European Agency for Safety and Health at Work, EU OSHA, are publishing discussion papers to help understand the risks and promote safe practices.
Good to know. Now, thinking about the wider societal impact, how is 3D printing changing the way we make things and maybe even the structure of our economy?
It's definitely forcing manufacturing firms to think differently, to be more flexible and adaptable. Advocates have long predicted that 3D printing might help counter globalization by enabling more localized production, making things closer to the point of need. While that's happening to some extent currently, it seems AM is more often complementing traditional subtractive manufacturing methods rather than entirely replacing them, at least for mass production. It excels in customization, complexity, and low-volume runs.
But some see it as more revolutionary than that.
Oh, yes. Futurologist Jeremy Rifkin famously claimed that 3D printing signals the beginning of a third industrial revolution, shifting away from centralized mass production. It's certainly having a tangible impact in areas like humanitarian aid. The ability to do distributed manufacturing printing needed supplies like medical devices or repair parts directly in remote or disaster-stricken areas can reduce transportation costs, minimize waste, and potentially foster local production economies.
That's a powerful idea. How else might it change society?
Well, it could further blur the lines between home and workplace, as more design and production potentially happens outside traditional factories, maybe more flexible work arrangements. It could even reduce the need for some high-speed freight services if more goods are made locally on demand. And as we discussed, those big questions around copyright legislation and intellectual property will continue to evolve as the technology becomes more pervasive.
And you mentioned this connection to commons-based peer production. What does that mean in this context?
It refers to the idea that 3D printing, especially when combined with open source designs and collaborative online communities, enables a different kind of production model. Instead of relying solely on large corporations and economies of scale, making lots of identical things cheaply, you can move towards economies of scope where the value comes from sharing infrastructure, like printers or digital designs, to produce a wide variety of customized things efficiently. Think shared workshops, makerspaces, online design repositories. However, alongside these positive visions, there are concerns. We touched on easier weapons manufacturing. There are also worries about the recyclability of some specialized materials, especially nanomaterials, and the potential for easier counterfeiting of goods.
This sounds like it could really shake up the job market, too.
Yeah.
What are economists saying about the potential impact on labor?
They're definitely discussing it. Some prominent economists like Larry Summers and Michael Spence have raised concerns about the potential devastating consequences for labor, particularly for routine manual and cognitive tasks that can be automated or replaced by technologies like AI and 3D printing. It forces us to have difficult conversations about wealth distribution, the future of work, and the need for new economic growth models, perhaps built more around digital technologies, creativity, and human capital development rather than traditional manufacturing labor.
That connection to local production is interesting. Any recent examples?
Yeah, a nice small-scale example from just this year, 2024. A 3D printer was donated to the Juan Fernandez Women's Group in a remote island community off Chile. It's helping them fix broken equipment locally, things they previously had to wait months for imports to replace. It perfectly highlights that potential for localized problem-solving and production.
That's great. Finally, let's talk about the environmental impact. It seems like a mixed bag. Are 3D printers ultimately good or bad for the planet?
It's definitely complex, with both significant benefits and some drawbacks. On the plus side, the biggest win is waste reduction. Compared to most subtractive methods that carve away lots of material, additive manufacturing typically uses only the material needed for the part, plus some support structures. This drastically reduces material waste. Less waste means less raw material extraction, less energy used in material processing, and often a smaller overall carbon footprint for the part itself. Localized production, if it takes off, also reduces transportation distances and associated emissions.
And enabling repairs.
Yes, that's another key benefit. Allowing consumers or local repair shops to create replacement parts for appliances or equipment can extend product lifespans, fighting against planned obsolescence and reducing the need to buy entirely new products. Plus, 3D printing is a key enabler of lightweighting in vehicles and aircraft, creating strong but lighter parts, which directly saves fuel and reduces greenhouse gas emissions during operation.
Okay, so a lot of potential positives there. What are the main environmental downsides?
The main concerns are around the energy consumption during the printing process itself. Some processes, particularly those using high-power lasers or maintaining high temperatures for melting metal or polymers, can be quite energy-intensive per part produced, especially compared to efficient mass production methods like injection molding for very large volumes. Also, while material waste is reduced, some of the waste that is generated, like support structures, failed prints, or unused powder bed systems, can sometimes be difficult to recycle, especially mixtures of materials or in highly regulated industries where material traceability is paramount.
But I assume research and industry efforts are trying to address these drawbacks.
Absolutely. There's a lot of work being done. We mentioned some large FDM printers that can now accept recycled plastics, like shredded milk bottles or PET pellets, as feedstock. And there are active efforts to develop more energy-efficient printing processes and to improve the recyclability of common printing materials, including producing metal powders from recycled scrap metal. The push is definitely towards making additive manufacturing a more sustainable and integral part of a future circular economy.
Wow. We've really covered a lot of ground today. We've taken an incredible deep dive into the world of 3D printing, tracing it from its surprisingly early sci-fi imaginings and conceptual patents all the way to being a truly transformative force. It's touching practically everything from medicine and aerospace to fashion, food, construction, and even how hobbyists create things at home. It's clearly a technology that offers unparalleled design freedom and customization, while fundamentally rethinking manufacturing efficiency and waste.
It really is. And it's clear that the full impact of 3D printing is only just beginning to be understood. Its evolution is ongoing, and it will undoubtedly continue to reshape our world in ways we probably can't even fully predict yet.
So here's something to think about as we wrap up. Consider this. As 3D printing continues to evolve, as it becomes even more accessible, making creation increasingly localized, and as the range of usable materials becomes even more versatile, How will our fundamental relationship with things, with physical objects, change? Will we genuinely become a society of universal makers, repairing and producing more of what we need on demand, right where we need it? Could this drastically alter global supply chains and our very concept of ownership and consumption? And maybe most importantly, what skills will be the most valuable in a world where theoretically almost anything can be printed? What does it mean to be a creator or a consumer in that future? Welcome, curious minds, to another deep dive.
Well, great to be here.
All right, today we're really diving deep into UNESCO. It's the United Nations Educational, Scientific, and Cultural Organization. You've given us this incredibly detailed source, a comprehensive overview from Wikipedia.
Yeah, it's quite expensive.
So our mission for this deep dive is to pull out the most important bits. We want to give you a clear, structured understanding of what UNESCO is, what it actually does, and some of the fascinating, sometimes pretty turbulent dynamics it deals with. At its heart, UNESCO is a specialized agency of the UN. Its goal is, well, ambitious, promoting world peace and security.
A huge goal.
Huge. Think of it as trying to build peace, but not with weapons. Instead, through international cooperation in education, arts, science, culture, all that.
Right, the soft power approach.
Exactly. It's about advancing sustainable development, human rights, by getting nations talking and working together.
And the source material we have, it really lays out this rich history. It shows you the journey, the diverse activities, and yeah, the controversies it's faced right from the start.
Plenty to unpack there.
Definitely. It gives us a lot to work with to understand its unique place.
Okay, so we'll trace its origins, look at its really impactful programs, and then, yeah, definitely take a closer look at the complex, sometimes tricky relationships with its member states over the years.
Sounds good.
Okay, let's unpack this. Where did UNESCO even come from? I mean, its roots actually go back further than you might think. Way back to the League of Nations International Committee on Intellectual Cooperation, the ICIC. Formed in 1922.
That's right. The ICIC was basically the world's first real attempt to get intellectual exchange going on a global scale.
With some big names involved, right?
Oh, yeah. People like Albert Einstein, Marie Curie, thinkers like that. It wasn't about politics or money, really, but about the power of ideas. The belief that sharing knowledge and culture could build peace.
That core idea seems central.
Absolutely. It's baked right into UNESCO's DNA.
But then World War II happened.
Exactly. And that dramatically interrupted those early efforts. But it also, paradoxically, shaped UNESCO's actual founding. There were these crucial wartime meetings. The Conference of Allied Ministers of Education came in London. And important declarations like the Moscow Declaration in 43, Dumbarton Oaks in 44, they all laid the groundwork. These weren't just, stuffy meetings. They were where leaders were thinking about a new kind of peace.
Built on more than just treaties.
Right. Built on shared understanding through education, through culture. And this all led up to that big UN conference in London, November 1945.
And that London conference, that was the key step. That's where 37 countries signed the UNESCO Constitution. Which then officially came into force November 4th, 1946, once 20 countries had ratified it.
The 20th ratification, yeah.
And the first Director General was Julian Huxley. What was the vision laid out in that original Constitution? How much did Huxley shape things early on?
Well, the Constitution itself has that famous line, "Since wars begin in the minds of men, it is in the minds of men that the defenses of peace must be constructed."
Powerful statement.
It really is. It emphasizes education, science, culture as the tools to prevent conflict. And Huxley, yeah, he was deeply committed to that intellectual scientific mission. He pushed for this universal humanist approach to global problems.
Okay, but things changed in terms of how it was run.
Yeah, that brings us to a really important point about governance. In 1954, there was a significant shift. The executive board members, they stopped acting in their personal capacity and started directly representing their governments.
Some more political.
Fundamentally, yes. It shifted how member states work together. It meant UNESCO became more directly tied to, and sometimes, vulnerable to, political wins.
Right.
And then, of course, bigger things like the Cold War, decolonization, later the fall of the Soviet Union. All these huge global factors kept shaping UNESCO's work, its priorities. It had to keep adapting.
Okay, so with that history set, Let's get into the core of what UNESCO actually does. The program areas. You mentioned 5.
That's right. Education, natural sciences, social and human sciences, culture, and communication information.
This is where it gets really interesting, seeing the impact. Let's start with education.
Okay. So in education, UNESCO did some really crucial early work fighting racism. It started with these influential statements by scientists in 1950, basically debunking race as a biological concept.
Right.
That led up to the bigger 1978 Declaration on Race and Racial Prejudice. And this work, it wasn't just theoretical. South Africa actually left UNESCO in 1955, citing issues over race. Only to rejoin in 1994 under Nelson Mandela, a really symbolic moment showing the impact.
That is powerful. And you can see practical stuff right from the beginning, too. What were some of the first real on-the-ground education projects?
Oh, yeah, right away. One early example was a pilot project on fundamental education, literacy, basic skills, in a Haiti's Marbelle Valley. That was 1947.
So hands-on from the start.
Definitely. And by 1948, UNESCO was already recommending that member countries make primary education free, compulsory, and universal.
Setting a high bar early on.
Exactly. And if you look at the bigger picture, the global movements, there was the 1990 World Conference on Education for All in Jomtien, Thailand. That really kicked off a huge push.
Right, getting education on the global agenda.
Mm-hmm. And then the 2000 World Education Forum in Dakar, Senegal. That's where governments committed to achieving basic education for all by 2015. And they didn't forget higher ed either. There was the 1998 World Declaration on Higher Education.
Okay, so education was key. But then there's culture. This is probably what many people know UNESCO best for, right? Heritage sites.
For sure. And the ambition there was clear pretty early on with projects like the International Campaign to Save the Monuments of Nubia, launched in 1960.
Ah, Abu Simbel.
Exactly. Moving the Great Temple of Abu Simbel plus like 21 other monuments piece by piece to save them from the Aswan Dam's rising waters. It was massive, the first and biggest campaign of its kind. It basically wrote the playbook for saving cultural heritage on a global scale.
And that work led directly to the World Heritage Convention.
It did, yeah. That foundational work resulted in the 1972 convention concerning the protection of the world cultural and natural heritage. That's the legal basis for the World Heritage List.
Okay.
The World Heritage Committee followed in 76, and the first sites were inscribed in 78. But UNESCO realized culture wasn't just about buildings and sites.
Right, living culture, too.
Precisely. Living traditions, expressions, they're just as vital. So that led to later agreements like the 2003 Convention for Intangible Cultural Heritage and the 2005 Convention on the Diversity of Cultural Expressions.
Interesting. Okay, moving on to natural sciences. UNESCO had a hand in creating CERN, the particle physics lab.
It did, yeah.
The European Organization for Nuclear Research, CERN, actually emerged from an intergovernmental meeting convened by UNESCO back in 1951.
Wow, so UNESCO is facilitating cutting-edge science collaboration from early on. Absolutely. It shows that early vision for science transcending borders. They weren't just funding, they were bringing people together for big international science projects.
Like what else?
Well, other early things included the Arid Zone programming from 48 to 66, focusing on sustainable development in dry areas. And importantly, in 1968, UNESCO held this conference trying to reconcile environment and development needs, which led directly to the Man in the Biosphere program, or MNEV. That was pretty pioneering, trying to balance human activity and nature.
Okay, makes sense. And the last area, communication and information.
Right. And that phrase, free flow of ideas by word and image, that's been in UNESCO's constitution since day one.
The direct response to World War II, right?
Yeah.
Propaganda and information control.
Exactly. They saw how dangerous that could be. So right after the war, efforts focused on, rebuilding media infrastructure, training journalists in the 50s.
But that led to some friction later on.
Oh, yes. The late 1970s saw this huge controversy around something called the New World Information and Communication Order, or NWITO.
What was that about?
Basically, it was a really heated debate. Developing nations argued that Western countries totally dominated global news and information flow. They felt it was unbalanced, undemocratic, and they wanted changes.
I can see how that would be controversial.
Definitely. It led to the McBride Report in 1980, which called for democratizing media more equal access. And the same year, UNESCO set up the International Program for the Development of Communication, the IPDC, to help build media capacity in developing countries.
So a difficult period, but did anything positive come out of it?
Actually, yes. A really significant positive outcome was the Windhoek Declaration in 1993. UNESCO's General Conference endorsed it. It was all about media independence and pluralism, a real landmark.
Okay.
And that led the UN General Assembly to declare May 3rd as World Press Freedom Day. Plus, since 1997, UNESCO has awarded the UNESCO Guillermo Cano World Press Freedom Prize, recognizes journalistic courage.
So complicated history there. But ending on a more positive note for press freedom, we've covered a huge amount of ground-saving monuments, education, science, free speech. But an organization like this, aiming for global cooperation, it must hit political walls sometimes.
Oh, absolutely. It's inevitable.
Let's unpack some of those major storms it's weathered, especially with member states.
Right. There have been some serious controversies. Take the 1980s withdrawals, that whole New World Information and Communication Order debate we just mentioned.
Yes.
Well, the US, the UK, and Singapore saw it very differently. They felt it was an attack on press freedom. So the US left in 1984, the UK in 85, Singapore later in 85.
Big blowback.
Huge. Though it's worth noting all three eventually came back.
Okay. What else?
There's been criticism regarding China. Accusations that UNESCO has been used perhaps to push a specific version of Chinese history, maybe downplaying contributions of minorities like Uyghurs or Tibetans. The Potala Palace in Tibet is sometimes cited as an example of how heritage is framed.
That raises tricky questions about national narratives versus a universal mission.
It does, and perhaps no area has been more consistently difficult for UNESCO than its relationship with Israel and Palestine.
Yeah, that seems incredibly complex.
Yeah.
Can you walk us through the main points?
Sure. It's definitely complex and diplomatically challenging. So Israel joined back in 1949. A flashpoint came in 2010. Israel designated 2 sites in the West Bank, the Cave of the Patriarchs and Rachel's Tomb, as national heritage sites.
Okay.
UNESCO responded by declaring them integral parts of the occupied Palestinian territories and used their Muslim names. That caused friction.
And then Palestine joined as a full member.
Yes, in 2011.
Mm-hmm.
And that triggered U.S. laws existing since 1989 that ban funding to any UN agency that accepts Palestine as a full member.
So the U.S. had to cut funding.
Immediately. The U.S. withdrew its funding, which was a big chunk, about 22% of UNESCO's budget. Israel also froze its payments.
Wow, major financial hit.
And a political one. Both the U.S. and Israel lost their voting rights in UNESCO's General Conference in 2013 because of the unpaid dues. Although, interestingly, the U.S. was still elected to the executive board for 2016-19, even without funding.
Strange situation. What happened with the Jerusalem resolutions?
That was another major point of tension. In October 2016, a resolution on East Jerusalem condemned Israeli actions and referred to the Temple Mount Haram al-Sharif complex primarily by its Muslim name.
And the reaction?
Israel froze all ties with UNESCO. Even the UN Secretary General and UNESCO's own Director General at the time expressed concern that the resolution could, obscure the deep historical connections of all 3 religions to the site.
So it was divisive even within the UN system?
To some extent, yes.
Yeah.
Ultimately, Israel announced its withdrawal, which became formal in January 2019. They cited ongoing anti-Israel bias and this feeling that Jewish connections to Jerusalem were being erased.
It sounds like a constant tightrope walk.
It really is, and it's not just one side facing scrutiny. There have been Palestinian-related controversies, too. In 2011, there was an issue with a Palestinian youth magazine, funded partly by UNESCO, that apparently praised Adolf Hitler. UNESCO withdrew the funding for that specific project immediately.
Right.
And in 2012, a decision to set up a UNESCO chair at the Islamic University of Gaza drew criticism from Israel, alleging ties to Hamas. The university denied those claims, but it shows how fraught everything is in that context.
It really illustrates the challenge of operating in highly contested political spaces. What's the long-term impact of these kinds of recurring funding issues and political tensions?
Well, the biggest impact is probably the challenge to UNESCO's universality, its claim to represent everyone, and financial stability, obviously. When major countries pull funding, it directly limits what UNESCO can actually do on the ground.
And it makes it look political.
Exactly. It fuels perceptions of politicization, which can undermine its credibility as a neutral forum for cooperation. It's a constant test of its core mission in a world that's, frankly, often deeply divided.
Were there other major funding disputes?
Yes, with Japan in 2015. Japan threatened to halt its funding because UNESCO included documents relating to the Nanjing massacre in its Memory of the World register.
Ah, sensitive historical memory issues again.
Precisely. Japan did suspend its 2016 funding payment over it. It highlights how differing historical narratives create friction.
And then there's the United States membership saga. It's been quite the roller coaster.
It really has a remarkable example of this political ebb and flow. So the U.S. first left in 1984, remember, citing politicization, hostility to free societies, budget issues.
Right, under Reagan.
Then they rejoined in 2003. But then, in October 2017, they notified UNESCO they were leaving again. That took effect at the end of 2018.
And the reason cited this time?
Similar themes, actually. Mounting arrears, the money owed since the 2011 funding cut the need for a fundamental reform, and again, continuing anti-Israel bias.
So a withdrawal, a return, another withdrawal, driven by recurring issues. But they're back now.
Yes. In 2023, the U.S. announced it wanted to rejoin and pay back its arrears over $600 million, explicitly mentioned countering Chinese influence as a reason.
Interesting motivation.
And they were readmitted in July 2023. However, and this is very recent, the White House stated in February 2025 it would review the membership. And then on July 22, 2025, the U.S. decided to withdraw yet again, effective December 31st, 2026.
Wow. In, out, in, out. It really underscores the fragility of that international commitment.
It certainly highlights the challenges. There have been other conflicts, too. A Turkish poet and goodwill ambassador, Zulfu Livaneli, resigned in 2016 over human rights concerns during the Kurdish-Turkish conflict.
Okay.
And even in 2020, controversies popped up about UNESCO statements on illicit art trade figures. An expert denied a $10 billion figure UNESCO used. And an ad campaign seemed to misrepresent some museum pieces as recently looted. So issues around accuracy and communication sometimes arise, too.
So despite all that turbulence, UNESCO still operates globally. What's the structure like?
Yeah, it maintains a pretty robust structure. The headquarters are in Paris, famous for its Garden of Peace. The main governing bodies are the General Conference of all members, the Executive Board, and the Director General who heads the Secretariat.
And its reach?
It's extensive. A global network of, I think, 53 regional field offices, plus 199 national commissions that link UNESCO to governments and civil society in member states. It really is a worldwide presence.
What about its current work? Beyond the big headlines, you mentioned things like protecting languages.
Absolutely. UNESCO does a whole lot across its program areas. In education, there's the international network of 644 UNESCO chairs fostering research. There's the long-standing 1960 Convention Against Discrimination in Education, and the UNESCO Associated Schools Network, ASP.NET, that's over 12,000 schools globally, promoting peace and intercultural understanding.
So really working at the grassroots level, too.
Definitely. Then there are public statements like the Seville Statement on Violence in 1989, which argued against the idea that humans are biologically wired for organized violence.
Challenging assumptions.
Exactly, and lots of designations, global geoparks, biosphere reserves like we mentioned, the Creative Cities Network like Cities of Literature, Edinburgh, Iowa City. There's the Atlas of the World's Languages in Danger, the Memory of the World Register for Documents.
That's the one Japan had issues with.
That's the one. It preserves significant documentary heritage. UNESCO also promotes ideas like freedom of expression, safety of journalists, universal access to information, and these Internet Universality Principles, ROAM.
ROAM.
Yeah, stands for rights-based, open, accessible, multi-stakeholder governance, trying to shape the Internet's future positively.
Oh, okay. Very relevant today.
They also organize events like the International Decade for the Culture of Peace, International Literacy Day, World Press Freedom Day, and specific projects like the Migration Museums Initiative, the Free Software Directory with the Free Software Foundation, even things like UNESCO that engage youth with heritage sites.
That's a huge range, and I read something about potential new lists, like for movable heritage paintings, artifacts.
Yeah, there have been proposals for new lists focusing on things like, say, the Mona Lisa or the Benin bronze's movable cultural heritage, and even one for the world's living species. Still under discussion, I believe.
Interesting. And for transparency.
They have the UNESCO Transparency Portal online where you can access info about their activities, budget, etc., trying to be more open.
Good to know. And its network extends beyond governments.
Oh, yes. It has official relations with over 300 international NGOs, plus specialized institutes and centers globally like the International Bureau of Education in Geneva or the International Center for Theoretical Physics in Trieste, Italy. And they award around 26 prizes across different fields, recognizing achievements.
So we've really journeyed through the massive scope of UNESCO. From those founding ideals of peace through education, science, culture, to concrete achievements like saving heritage, promoting literacy, championing free expression.
And we've definitely seen how it's navigated some really significant political and financial storms along the way. Withdrawals, funding cuts, intense debates.
Yeah.
But what's striking, I think, despite all that turbulence and the sometimes wavering support from major powers like the U.S., is its resilience, its continued relevance.
Why do you think it endures?
Well, maybe it points to this fundamental need, a need for global collaboration on shared challenges, education, heritage, science, information, things that really no single country can tackle alone, even when the political climate gets rough.
A fascinating perspective.
Yeah.
So thinking about everything we've discussed, UNESCO's ambitious goals, its successes, but also its very real struggles and controversies, it leaves us to the question for you, the listener. What do you think is the biggest challenge facing an organization like UNESCO today as it tries to foster global peace and understanding in our world, a world that's more connected than ever, yet often feels incredibly polarized? Okay, let's unpack this. Today, we're doing a deep dive into something, well, truly extraordinary, I think. A game that didn't just entertain people, it genuinely changed how millions interacted with the world around them.
Uh-huh.
We are, of course, talking about Pokémon Go.
That's right. And this isn't just, reminiscing about a mobile game. It's looking at a cultural phenomenon, a big technological step, and honestly, a fascinating business story, too.
Absolutely. So for this deep dive, we've gone through a stack of sources, mainly a really detailed Wikipedia excerpt to kind of pull out the core essence of Pokémon Go.
Which is, for anyone who somehow missed it, an augmented reality mobile game developed by Niantic working with Nintendo and the Pokémon Company, launched back in 2016 for iOS and Android.
And our mission really is to give you a shortcut, a way to get properly informed about this incredible journey without reading hundreds of pages. We want to pull out the key bits of knowledge, the insights, get beyond just the facts to the why and the how.
Yeah, understand its core concept, how it evolved, often in surprising ways, its massive impact, and even, the very recent corporate shifts.
Exactly, how it blends virtual and real. And believe me, its story has been, well, anything but simple.
Definitely not. So, at its core, Pokémon Go uses your phone's GPS. It creates this augmented reality experience.
Right.
So these virtual Pokémon, they appear like they're right there with you, in your real-world spot, ready for you to find, catch, train, and battle.
And it's free to play, but obviously.
Obviously, yeah. There's a freemium model, so supported by in-game purchases, special events, that kind of thing.
And your whole journey kicks off with creating an avatar.
Yeah.
Which, funnily enough, has actually been its own little saga.
Oh, yeah.
Well, initially you could customize clothing, based on season, your level, maybe sponsors. But then, and this is kind of interesting from a game dev perspective, April 2024, they updated it. More hair, body size, skin color options.
Sounds good on paper, right? More inclusive.
You'd think.
Yeah.
But it actually got quite a lot of backlash from players.
Really? Why was that?
People felt the new avatars just looked worse, graphically inferior, which is one thing. But maybe more importantly, the update messed with cosmetic items people had paid for.
Ah, okay. That's the friction point, isn't it? In these freemium games, people spend real money on virtual stuff. If you change it later, diminish its value, or make it glitchy.
Yeah, people get angry fast. It really shows that tricky balance, Innovating versus respecting what players have invested in, especially in these live service games.
That's a really key point. So, okay, you've got your avatar, maybe slightly controversially updated.
Oh.
And you're out there, exploring the real-world map. Your digital character moves as you move.
Right. And the map's dotted with these things. Pokestops, little icons, and Pokemon gyms, bigger towers, usually at places of interest.
Which initially caused some, let's say, unique placements.
You're talking about the ingress data.
Exactly. Niantic's previous AR game, they basically repurposed crowdsourced locations from Ingress. Efficient, sure, but it meant Pokestops and gyms popped up in some really awkward or even dangerous spots.
Like where?
Well, there was reportedly a gym, now deleted, obviously, right in the Korean demilitarized zone.
Wow.
Or Bagram Air Force Base. It just shows those unexpected problems when you layer a game onto the real, messy world.
Definitely. Though they did fix that later, right? Players could submit locations.
Yeah, since 2019, players could suggest new spots, which was Frankly, crucial. A bit of community course correction.
Makes sense.
Yeah.
And then you have the items you can buy. Incense.
Right. Incense tracks Pokemon to you as you move. Lure modules, you attach those to a Pokestop, and they attract Pokemon to that spot, helping everyone nearby.
And lucky eggs double your XP for a bit.
Yep. And when you get Pokemon, their strength is basically measured by combat power, CP. And there's an appraisal system, too. Lets you check their hidden stats, their potential.
Okay, so collecting Pokemon. How does that actually work compared to, say, the main games on Switch or DS?
It's quite different, actually. You don't battle wild Pokemon to weaken them. No, you just flick a Pokeball at them on your screen. Success depends on, like, the Pokemon's base catch rate, your timing, the type of Pokeball, stuff like that.
And when you catch them, you get candies and Stardust?
Correct. Candies are specific to that Pokemon's evolutionary line. You need them to evolve or power up that specific type. Stardust is more universal. You use that to power up any Pokemon.
Gotcha. And you can transfer extras to Professor Willow.
Yeah, frees up storage space and gives you a bit more candy for that type of Pokemon.
And the game keeps growing, right? The level cap went up.
It did. From 40 up to 50, back in November 2020, gave veteran players new goals. Plus, there's always the hunt for shiny Pokemon, those rare color variants.
Yes, the shinies. And the ultimate goal for many, completing the Pokedex. Catching them all, basically.
And Niantic kept adding features to the collection side. Remember Buddy Pokemon? September 2016?
Oh yeah, you pick one to walk with you on the map.
Exactly. Earns rewards, specifically candy for that Pokemon based on how far you walk. A great incentive to keep moving.
And community days, those became huge.
Totally. Started January 2018. Monthly events, boosted spawns of one specific Pokemon, exclusive moves if you evolved it during the event, higher shiny chances.
Brilliant way to get people playing together consistently. First one was Pikachu, wasn't it?
It was indeed. Pikachu kicked it all off.
I remember the buzz around those early ones.
Yeah.
And they just keep adding Pokemon, don't they?
Constantly. As of, early 2025, there were 884 species in Go. Out of over 1,000 in the whole franchise now.
Including regional ones, right? To encourage travel or trading.
Yep, like Unova Pokemon in September 2019. And of course, the big ones, legendaries, mythicals, usually dropped in special events. Like Groudon, December 2017, creates real excitement.
What was that unique mythical one that debuted in Go? Meltan?
That's the one, Meltan and its evolution Melmetal. The only mythicals to debut first in Pokemon Go. Really clever tie-in with the Switch games Let's Go, Pikachu, and Eevee.
How did that work again?
You transferred Pokemon from Go to Let's Go, and you'd get this mystery box item in Go that temporarily spawned Meltan. Great synergy.
Smart. And then Mega Evolution came along too.
August 2020. Introduced those powerful temporary Mega forms. Started with just 4, but expanded to, I think, 40 forms eventually. Added a whole new strategic layer to battles.
Right, battles. Let's talk about the combat system. It's evolved quite a bit too, hasn't it?
Hugely. So you hit level 5, you pick a Team Instinct, Mystic, or Valor, yellow, blue, red. Then you can battle at gyms.
And the gyms themselves changed a lot, June 2017.
A big revamp then, yeah. Made them more about teamwork. You could spin the gym disc for items, like a Pokestop, capped at 6 unique Pokemon per gym.
And how you earn coins changed too, right? Based on how long your Pokemon defended.
Exactly. Encouraged more sustained engagement, trying to hold gyms longer. But importantly, you couldn't put legendaries, mythicals, or your buddy Pokemon in gyms. Kept things a bit more balanced.
Good call. Then came raids, July 2017. That felt like a huge deal.
Oh, it was massive. Groups of players teaming up to fight superpowered Pokemon, win, and you get a chance to catch a regular version of it.
And the hardest ones, level 5, those were for legendaries.
Yep. Articuno and Lugia were the first ones, launched right after that. Yeah. Infamous Go Fest in Chicago in 2017.
Ah, yes. Well, maybe touch on that later. And raids kept evolving too. Mega raids.
Mega raids in August 2020 for Mega Pokemon materials. And then even Mega Legendary Pokemon got their own 6-star raids like Mega Latias and Lashios in May 2022.
It's super tough.
And then even newer types. Elite raids.
October 2022. Extremely hard. In person only. They'd announce like 24 hours in advance where they'd hatch. Made them real community events.
And shadow raids.
May 2023. Battling those Team Go Rocket Shadow Pokemon.
Yeah.
They had boosted attack, lower defense. You could catch them after winning. And they had this enraged state. You needed a special item, a purified gem, to manage. Initially in person only, but that changed later.
So much battling. What about player versus player? That took a while, didn't it? It did. Highly requested. Trainer battles finally arrived in December 2018. Then, building on that, January 2020 saw the Go Battle League launch.
Which is the online competitive mode.
Exactly. Formal online ranked play. Pairs you globally with players of similar skill using an ELO rating system, like in chess. It's 3-on-3 battles, fast moves, charged moves, shields to block attacks, strategic switching.
So proper competitive play, and there are different leagues.
3 main ones based on combat power caps. Great League is 1500 CP max, Ultra League 2500 CP max, and Master League is no limit.
And this actually became part of the official Pokemon scene, right? World Championships.
Amazingly, yes. Pokemon Go was added to the official Pokemon World Championships in 2022, 2023, and 2024. You qualify through the Go Battle League. Huge validation for a mobile game to be on that stage.
Wow, okay. What about Team Rocket showing up?
Team Go Rocket Battles started July 2019, added a bit of narrative flavor. You'd battle NPCs at Pokestops or in these hot air balloons that appeared.
And winning lets you catch shadow Pokemon.
Yeah. They have that attack boost but defense penalty. You get the choice. Keep them as shadows or purify them, which boosts their stats back up, lowers cost, and lets them learn an exclusive move. Adds another strategic decision.
And just recently, late 2024, Dynamax arrived from Sword and Shield.
Yep, September 2024, Dynamax battles. Up to 4 players, in person or remote, take on a giant Dynamax Pokemon. You use special MP currency, fill a meter to Dynamax your own Pokemon, use powerful max moves. Only specific Pokemon can Dynamax, though.
And then Gigantamax followed right after.
October 2024. Similar idea, but even bigger scale. Up to 40 players in one Gigantamax battle. Again, only specific Pokemon caught from these raids can Gigantamax, really pushing the scale of cooperative play.
Incredible evolution. Let's rewind, though. Where did the whole idea even come from?
It's a great origin story, actually. Conceived back in 2014, Satoru Iwata from Nintendo and Tsunekazu Ishihara from the Pokemon Company.
And it started as an April Fool's joke.
Pretty much. A collaboration with Google called Google Maps Pokemon Challenge. You could find Pokemon on Google Maps.
Huh? I remember that.
But Ishihara was already a fan of Niantic's earlier game, Ingress. He saw its location-based, augmented reality concept and thought, this is perfect for Pokemon.
And Niantic ran with it. They were part of Google then.
Initially, yes. They spun off as independent in 2015, but they used that crowdsourced Ingress data for the Pokestops and gyms. Google Maps data helped decide where Pokemon appeared based on terrain. Later, they switched the visual map display to OpenStreetMap data.
And didn't the game's tech actually help improve other software?
That's right. Its massive scale, running on the open-source Kubernetes system for managing all its server components, actually helped find and fix bugs in Kubernetes itself. The game was pushing the limits of existing tech.
Amazing. Who were the key people behind it?
Tatsuo Nomura was the director at Niantic. Junichi Masuda, the legendary Pokemon composer, was involved in design too. And Dennis Huang, known for designing the Gmail logo, was the graphic designer.
So before the global launch, they tested it.
Yeah, crucial beta testing. Started just in Japan, March 2016, then expanded to Australia, New Zealand, the US. Got essential feedback before the big rollout that summer.
And after that explosive launch, the evolution continued nonstop.
Yeah.
Comic-Con 2016.
Right, John Hankin, Niantic's founder, was there, revealed the team leaders Candela, Blanche, Spark. He famously said only about 10% of their ideas were even in the game yet, promised things like trading, more Pokemon, even Pokemon Center.
And fixing that annoying 3-step glitch.
Yes, promised a patch for that too, and said they'd support the game for years to come, which, you have to say, they certainly did.
We saw big collaborations pretty quickly too. Starbucks. Sprint.
Late 2016, early 2017, they became sponsored locations, Pokestops, and gyms right in their stores, showed the game's commercial appeal early on.
That was an Apple Watch app.
December 2016,
Yeah.
a companion app. Then Gen 2 Pokemon from Johto arrived February 2017. 100 new species, new berries, more avatar clothes, always adding content.
And Gen 3, Ruby and Sapphire, later that year. The weather system.
Yeah, late 2017. The real-world weather started impacting the game. Certain types appeared more often in rain, sun, etc. Added another layer of immersion.
And the links with the main series games got tighter. Let's go! Pikachu and Eevee on Switch.
November 2018. Those games were heavily inspired by Go's catching mechanic and had that deep integration for transferring Pokemon, especially for getting Meltan.
Right, Melton debuting in Go first. September 2018, that felt significant.
It really highlighted Go's growing importance within the whole Pokemon ecosystem. Gen 4 Pokemon started appearing around October 2018, too.
Any big quality of life improvements around then?
Adventure Sync. October 2018, that was huge. Let the game track your walking distance even when it was closed, using Apple Health or Google Fit data. Made hatching eggs and earning buddy candy so much easier.
Game changer.
Definitely. John Hank even said in early 2019 that 2018 was the year Go finally became the game initially envisioned by Niantic. Like, it had reached maturity.
And then 2020 happened. COVID-19.
Yeah, a massive curveball. Niantic had to make huge adjustments for people stuck at home. Indoor step tracking, letting you battle friends remotely, making Incense way more effective, boosting spawn points, doubling the interaction radius.
Critical changes to keep the game alive during lockdowns.
Absolutely essential. Showed a willingness to adapt, even if it temporarily went against their Go Explore philosophy.
Let's not forget the hardware. The Pokémon Go Plus device.
Right. Nintendo developed that, released September 2016. Little Bluetooth wearable, looked like a Pokeball mixed with a Google Maps pin.
Let you catch stuff without looking at your phone.
Exactly. It would buzz and light up. You press the button. Simple actions. Then the Plus Plus came out July 2023, added auto-catching and auto-spinning Pokestocks, plus sleep tracking features, continued integration into daily life.
Okay, the rollout itself, it started July 6th, 2016. Australia, New Zealand, US.
Yep. But the demand was just insane. Servers buckled immediately, experienced 50 times the expected traffic.
50 times. Wow.
So they had to pause the global rollout. Japan's launch got delayed, partly because a McDonald's sponsorship deal leaked early. France's launch was postponed respectfully after the tragic, terrorist attack showed real-world events impacting the virtual rollout.
What about places like South Korea or China?
Yeah.
Unique challenges there.
Big time.
Yeah.
South Korea has mapping restrictions, but somehow a glitch made this one small area, Sokcho, playable. Bus tickets sold out instantly as people rushed there.
That's wild.
And that DMZ gym popped up briefly. Mainland China, Google services are banned, GPS blocked. Players had to use clones or VPNs, always a cat and mouse game.
Wasn't there that guy in Taiwan with dozens of phones on his bike?
Uncle Pokemon, yeah, became an internet legend, rigged up like 70-plus phones to play super efficiently, shows the dedication or obsession.
And the game just kept rolling out. Saudi Arabia as late as October 2024.
Yeah, demonstrates that long-term global strategy, still expanding years later.
Okay, the money side. The commercial reaction was intense.
Yeah. Intense is an understatement. Nintendo's stock price just exploded, up 10% initially, then 50% by mid-July, more than doubled by July 19th. Added $9 billion to their market value in, 5 days.
Insane. But mostly based on hype.
Largely speculative, yeah. Investors weren't necessarily reacting to Go's immediate profit for Nintendo, but dreaming about what future Nintendo mobile games might do.
Until Nintendo poured cold water on it.
Pretty much. July 25th, the stock dropped 18%. A $6.7 billion fall. Nintendo clarified they only had about a 13% effective economic stake in the game's profit. A big reality check for the market about partnership structures.
But other companies did benefit.
Oh, yeah. Tommy, the toy maker, TV Tokyo, even Zag, making battery cases because Go drained phones like crazy. Their stocks jumped too.
But the launch itself, technically.
A bit of a mess.
A huge mess. Those server outages were constant. Remember, 50 times expected traffic, 10 times their worst-case scenario. Crashes, login errors. It was rough for days. A hacking group even claimed they caused an outage in July 2016.
And there was that early security scare with Google accounts. Right. Some early iOS versions mistakenly asked for full Google account access, caused immediate alarm. Niantic had to quickly clarify it was an error, no unnecessary data was accessed, and patch it fast. Vital for user trust.
And the glitches.
Oh,
This three-step glitch.
Ugh, that was infuriating. Mid-July 2016, the tracking system just broke, showed every nearby Pokemon as 3 steps away, making it useless. Then Niantic just removed it entirely on July 30th.
Which players loved, I'm sure.
Not exactly. Huge backlash. Felt like they'd lost a core feature. Plus other things, like Pokemon randomly swapping during transfers, even some legendaries getting out accidentally and needing to be recalled. Managing a live game at that scale is tough.
So what did actual reviewers think? Mixed bag.
Pretty much mixed or average, according to Metacritic. Around 6.9 to 100, everyone loved the concept, the AR innovation, but the technical problems were impossible to ignore.
What were the big positives mentioned?
Hugely enjoyable, people said. A real social experience, almost like an MMO, but out in the real world. And the exercise. Got called the greatest unintentional health fad. People walking miles further than usual. IGN even put it in their top 100 games later on.
But the negatives were significant, too.
Definitely. Constant crashes early on, gameplay felt shallow initially, server problems obviously, that three-step glitch fiasco, and a really big one, the massive disadvantage for rural players. Far fewer Pokestops gyms, just not the same game, plus accessibility issues for people with disabilities.
Exposed those real-world inequalities, didn't it?
Absolutely. Hard to make a location-based game truly fair for everyone.
Okay, forget reviews for a second. The sheer numbers, downloads, revenue,
Yeah.
just staggering.
Astronomical. 2016 was wild. Topped app charts instantly. Fastest game ever to 10 million downloads, like within a week. 100 million by the end of July. Most active mobile game in the US ever by mid-July.
And the money.
Over $160 million by end of July 16. $600 million in its first 90 days. Fastest mobile game to hit that mark. Daily usage beat Snapchat, Tinder, Twitter, Facebook. Wow. 5 Guinness World Records in its first month. Ended 2016 with estimated $950 million revenue. Even though usage peaked mid-July and dropped off significantly by September, which is normal for mobile, a Halloween event then boosted revenue 133%, showed the power of events.
And it didn't stop there. Kept making money hand over fist.
Kept rolling, hit $1 billion revenue by February 2017, fastest again, over 1 billion downloads by early 2019. Annual revenue stayed huge. Nearly $900 million in 2017, $1.3 billion in 2018, $1.4 billion in 2019.
And then 2020, the pandemic year, it made more money.
Paradoxically, yes.
Yeah.
Its highest revenue year ever. $1 billion in the first 10 months, $1.92 billion for the whole year.
Yeah.
Those remote play changes were incredibly successful financially. Cumulative revenue hit $6.46 billion by the end of 2020. Just phenomenal numbers.
Beyond the money, the cultural impact, it felt like everyone was talking about it.
Pokemon Go mania, they called it. A true social phenomenon. It genuinely brought people together out onto the streets.
Had some weird positive side effects too, right? Like helping police.
Yeah, stories of players stumbling upon crimes in progress, or police using the game for community outreach. Businesses, especially small local ones, saw huge foot traffic increases if they were Pokestop or used lure modules.
Turned boring commutes into adventures.
Highlighted local history people never noticed. Brought folks into churches or temples just because they were gyms. Sparked a whole secondary market for selling accounts or offering coaching.
Big companies noticed too. T-Mobile, Yelp.
T-Mobile offered free data just for Go players for a while. Yelp added a filter so you could find businesses that were Pokestops. National parks, museums reported more visitors. Even charities got creative dog shelters organizing walks so people could hatch eggs.
Amazing. And it just permeated pop culture. Politicians mentioning it.
Rio's mayor wanted it before the Olympics. Trump and Clinton campaigns referenced it. An MMA fighter did a Pokeball celebration after a knockout. The Rock made a promo video.
Huge boost for AR visibility too.
Massively credited with popularizing augmented reality for the mainstream, got praise from gender-fluid groups for avatar options. Positive impacts reported for individuals with autism, providing structure, encouraging interaction.
Even affected music and TV.
The original Pokemon theme song saw a massive streaming spike on Spotify. Pokemon series and movies saw viewership jump. It even boosted sales of the older Pokemon games on the 3DS. A rising tide lifted all Pokemon boats.
Spoofed everywhere, naturally.
Maroon 5 video, Doctor Who, The Simpsons. It was just everywhere. Undeniably sparked a huge resurgence for the entire Pokemon franchise.
What about actual live events? GoFest.
Ah, yeah. The first big one, Chicago 2017. Technically disastrous, major connectivity problems, people couldn't play, led to refunds, lawsuits, a real learning experience for Niantic.
But the smaller community days worked well.
Those became incredibly successful. Monthly, manageable, built a great sense of regular community engagement. And on a totally different note, that art project, Pokemon Go in Syria.
Oh, right. Powerful stuff.
Kaleidokeel's photos. Placing Pokemon in photos of war-torn Syrian streets went viral. Used the game's familiar imagery to draw attention to a horrific reality, a really striking artistic response.
But it wasn't all positive vibes and community days. There was real criticism. Serious incidents.
Definitely. The location sensitivity was a recurring problem. Pokestops at Auschwitz, the Holocaust Museum, the 9/11 Memorial, deeply inappropriate. Niantic did eventually implement ways to remove them from sensitive sites.
And just general safety concerns.
Loads. Railway operators complaining about people on tracks, fire stations asking to be removed as Pokestops, police warnings worldwide about distracted driving, trespassing, players being lured into robberies.
New York banned sex offenders from playing. Bosnia warned about landmines.
Yes to both. Shows how the game collided with really serious real-world dangers and regulations.
And tragically, people actually got hurt. or worse?
Sadly, yes. Numerous accidents. The first reported death linked to it was a distracted driver in Japan, August 2016. A girl killed by a car in Cambodia. That shooting death of Jian Shengchen in Virginia in 2017 while he was playing, stark reminders of the dangers of distraction.
Governments and religious groups got involved too.
All sorts of reactions. Some religious leaders called it harmful mania or even linked it to Satanism. Countries like Kuwait, Indonesia, Israel, Saudi Arabia, India, Malaysia, Thailand, Vietnam, Philippines. Many imposed bans or restrictions, citing security, safety, moral concerns.
Security worries were quite widespread.
Yeah, Russia's government suggested it could be used by foreign intelligence. Iran banned it outright. The Pentagon banned it on Defense Department properties. UK police reported hundreds of incidents related to the game just in its first month. Generated a lot of friction.
And cheating was always an issue. Glitches.
Constant battle for Niantic. They stopped supporting things like Cyanogen mod to curb cheating. That three-step glitch and the legendary Pokémon mistakes really hurt player trust, and people even started vandalizing OpenStreetMap data to try and manipulate gym or stop locations in the game.
Wow. What about unofficial apps, trackers and stuff?
Big market for those emerged immediately. Apps like PokeRadar that crowdsource locations became hugely popular, showing the demand for better tracking. GoChat for location-based chat blew up too.
Not risky.
Very. Lots of fake apps filled with malware popped up. And Niantic actively shut down popular tracking sites like Pokevision that scraped game data, citing terms of service violations. Constant tension there between what players wanted and what Niantic allowed.
Right, let's jump way forward to very recent massive news, the sale.
Right. March 2025, huge announcement. Niantic selling its video game division, including Pokémon Go, to Scopely.
Scopely, backed by Saudi Arabia's public investment fund. For how much?
$3.5 billion. The deal included Go, Pikmin Bloom, Monster Hunter Now, plus the Campfire and Wayfarer apps.
What did Niantic keep?
They spun off a new entity, Niantic Spatial, led by John Hank. It kept the original game Ingress and Peridot, focusing more on the underlying AR platform tech.
So a major strategic shift for Niantic, and the deal went through.
Completed May 29, 2025. Unfortunately, it did also involve layoffs at Niantic's HQ, the tough business side of these huge deals.
And finally, those COVID changes. We mentioned Niantic rolled some back in 2021, causing that hashtag Niantic backlash.
Right. They initially reverted the interaction distance, for example. Players were furious.
But many of the pandemic-era adjustments actually stuck around permanently, didn't they, as of 2025?
They did. Niantic eventually listened on some key points. That 80-meter interaction distance for stops and gyms, it came back permanently in August 2021 after the pushback.
No, stayed. Remote raids.
Fully integrated now. You can use up to 10 remote raid passes a day for Shadow and Max battles, buy bundles online. Incense still has its boosted pandemic duration and spawn rate. Adventure Sync is still tracking background distance. Even the higher cap on opening daily gifts remains.
So the game did evolve permanently because of that period and the feedback.
Absolutely. It adapted to player behavior and, let's be honest, the reality of modern mobile gaming. It's a more flexible game now than it was pre-pandemic.
So, wrapping this all up, what an incredible journey Pokemon Go has had. From that April Fool's joke origin.
A global cultural earthquake, technical nightmares, constant evolution, huge financial success, and now new ownership under Scopely.
It really is a game that did more than just entertain. It changed behavior, changed how we thought about digital stuff, interacting with physical places, built communities in new ways.
Absolutely. It broke new ground, showed the potential and the pitfalls of mainstream augmented reality.
So here's the final thought to leave you with. Given this groundbreaking history, its incredible staying power, and now this major shift with the sale, what does the future actually hold for Pokemon Go under Scopely? How might its journey continue? Will it keep shaping how we see AR, how communities form around games in the real world, and just, how we navigate this increasingly blended digital and physical reality?